Hey, it's Uncle Ben, here with another edition of Life Hacks. It's 4 p.m. on Thursday, March 2nd, 2023. And I just did something very silly. In an effort to clean my nonstick pans, I put them in the oven for a clean cycle. It turns out that they're only rated to 500 degrees Fahrenheit. I know for a fact that the oven's clean cycle goes above 500 degrees Fahrenheit because I have... Anyway. Most likely, the oven clean cycle goes above 500 degrees Fahrenheit. So, earlier today, when I opened the oven after the clean cycle, the pans had a light blue tinge to them. Now, to my knowledge, there are very few light blue powders that are healthy for you. There's not many first of all, there's not many naturally occurring substances that are blue. I know I'm wearing blue and then there's blue back there. But yeah. Basically, it goes to show of sometimes if you're doing something for the first time and you don't know and you have not asked anyone about it, it's worth doing a 2-minute Google search. Yeah. We have these things called phones. And they have this thing called the internet, which within the span of 5 minutes, you can access 80+% of the accumulated knowledge of the entire human race. I think that's pretty powerful. And I think that's something that people should use more often, along with common sense, which I did not employ there. I admit I was in a rush, but there are very few situations in which doing it correct, making sure, double checking that you're doing it correctly is a bad thing. If there is a strict time element to it, which includes life or death, it's the only reason that you shouldn't confirm what you're doing. It's one of those things of measure twice, cut once, because not necessarily like a safety thing, right? It's not necessarily because it's not saying that people are naturally fallible, which they are. By the way, that word is fallible, not fallible. I misspoke. But the point here is take your time. And yeah, don't let pride get in the way of safety. That's the one thing that that is totally reiterated again and again and again and again and again. But some fun stuff that happened today. They are currently cleaning the windows outside, which have evidently not been done for multiple years. Because I was here last year in Keys, the Keys complex, and there was no window cleaning, and the windows were kind of dirty last year. So that probably means that they haven't been cleaned in probably 4 years. I don't think they would have cleaned it COVID year. And so, yeah. Anyway. I'm currently working on a submission for a class, or for cell lab, the class cell lab, in which we thawed cells, a cell culture. We were using 3T3 cells, which I don't expect anyone who isn't in biology or life sciences to know that, or what that is. It is fibroblasts, I believe. I believe that fibroblasts are... Hold on, I need to look this up for myself. Let's see. It doesn't say what there are. Fun. But one of the interesting things here, and there are some learning tips here, and reiterating for myself. So, to preserve these cells, they are frozen. When you decrease the temperature of something, the chemical activity of it goes down. So, it's similar to how a warm soda is more likely to fizz and overflow than a cold soda, because the rate of chemical and physical things decrease with decreased temperature. Moving on. There's a more detailed explanation there for another time. The same thing applies to living things. The same concept applies to living cells. When you freeze them all the way down with liquid nitrogen, mind you, so this is, I believe, negative 70 degrees Celsius, which is really, really cold. I don't think that there is no... It's colder than anywhere we know of on Earth. And, yeah. So, what's it called? To do this, you have to put in a special chemical so that the cells don't die from the freezing process. When something freezes, or when water freezes, going from liquid to solid, ice expands. Ice being the solid form of water. This is not common, but this is why icebergs float. Why ice floats on water. Because ice is less dense than water. Meaning that as water freezes, the molecules of water get further apart from each other, and therefore the entire volume increases. Which, if you have cells in this water, as the water freezes, the cell membranes are going to be stretched but everything is really cold at that point. So the membranes are not very stretchy. So if you get to that point, there's a potential for the cells to break and for that membrane to shatter, and it's not good. So there are certain molecules that you can use that actually help with that process. I don't know exactly how it works for this particular one, but it is a kind of cellular antifreeze. A lot of fish that live in the Arctic, yes, there are fish that live under ice, which is a crazy concept for another time. But this chemical at room temperature or at body temperature, which you keep mammal cells, the ones that I've been working with are mouse cells. You keep them at body temperature so that all of the proteins work properly. Just like any other chemical reaction, the speed at which proteins work and if they work or not depends on the temperature and acidity and the concentration of a bunch of other things. But a big one is temperature. So if you don't have your cells at a certain temperature, they don't work properly. At this temperature, the chemical that is used to protect these cells when they're frozen is actually quite toxic. And so you don't want your cells in that environment. It's kind of like a jacket. If you have a jacket and you're somewhere cold, that's good. But if you're wearing that same jacket all buttoned up in the desert, you might overheat. This is an analogy, not actually what happens. So that means that immediately upon defrosting the cells, you need to separate the cells from the toxic molecule. And the way to separate things in solution is to centrifuge it, which is a really cool process. You spin something so fast that the solution itself will organize in terms of density. It's kind of like if you had, I don't know, it's a topic for another time. It's really cool. But yeah, basically spin it really fast, and then you get this gradient or distribution of different layers. It's especially cool if you have different colors. This was not different colors. Basically, you have your cells at the bottom and all liquid on top you have to get off. Anyway, I thought that part was really cool. One of the things that, I don't know. Yeah, I just thought it was cool. But it's, anyway. There's not that. See, I don't think that there's any other things to talk about at this time. I guess I got new sunglasses. I had been without sunglasses for like a week, then I went and got them. I've had this kind of pair before, and I think they're really cool. They got the nice blue film to them, and they're pretty sleek. They're for $20 sunglasses, they're fairly sturdy. Don't sit on them. Have had that happen before. But my previous pair, I think I have right here. I guess it's a similar style. It's not the exact same. But beyond this little bit of damage here, basically all that happened was the lenses got scratched. So, there's a back and forth between whether you buy something that's going to last a long time or something that you can buy repeatedly. And that's a decision you have to make by yourself. Anyway, I will leave it at that for the moment. For now, I've been Uncle Ben. Thank you very much for watching. I love you. See you next time.